All right. Hey, everybody. Thank you so much for joining our Maximizing Connect series. This is part of a full series we're running this year, and today's session is going to be on IVR and conversational AI. And each of our Maximizing Connect workshops has a business component one day, a technical component the next. So be on the lookout as we get more scheduled. Otherwise, I'm going to pass it off to Mike and Gillian to get us started.
Thanks, Alex. Oh, Mike, I think you might be muted.
I sure am. Thank you. Can you hear me okay now?
Yeah.
Yes.
Cool. So thanks, Alex. Like she mentioned, my name is Mike Nolan. I'm a senior solutions architect here at AWS out of Chicago. I am coming to you live from the Minneapolis office today, however. I'm excited to talk to you all about how to get the most out of your IVR and Amazon Connect today. Gillian, you want to give yourself a quick intro?
Sure. I'm Gillian Armstrong. I'm also a solutions architect in the Amazon Connect space, and I'm in the United Kingdom and coming to you not from the cool office, but from my house in Belfast.
Great. So just for agenda today, we're going to be going through how Lex works. To some folks, it might be a little bit of a black box for those unfamiliar with automatic speech recognition and natural language understanding. So we're going to peel back the onion on that a little bit and level set on terms and kind of how Lex works with those in the interaction model. And then we're going to talk about some of the best practices with the Lex interaction model. I will tease, Gillian has written a fantastic blog on this, which we'll be setting up a link for later that covers even more of this, but we're going to cover some of the top items there. And then we're going to talk through Amazon Lex and Lambda integration, specifically code hooks. So how you can kind of have this better together story of using Amazon Lambda and Amazon Lex to curate these exceptional customer experiences. Finally, then, we're going to talk about how to get the most out of your IVR, covering some of the new ASR features that have come out in the last year, and see how they can be leveraged to improve your overall ASR efficacy, including some live demos that hopefully are going to go great. After that, we're going to have a quick survey. Everything here that we do here at Amazon is data-driven, so please complete the survey so we know how to improve, and it also allows us to do more of these for you all. And then finally, we're going to try to save some time for Q&A, so we'll use the chat functionality within Chime for that and try to answer some of your questions. Great. If there's no questions there, Gillian, I'll hand it off to you to kind of kick us off and talk about how Amazon Connect or Amazon Lex works.
Thanks, Mike. Let's jump in. So here we go. Now, so we will be jumping into some of the deeper details, but before we do that, let's just spend a few minutes running over the high-level pieces of what is happening when we call Lex. So here we have our lovely customer, and she's going to call into our Amazon Connect contact center and be connected to our Lex bot. And the bot is going to take an utterance, which is just what the customer said, and then using automatic speech recognition, or ASR, convert that speech to text. And all of the inputs to our next piece, the interaction model, will come in as text. So the transcription piece is a really key piece, and that is why we're going to spend so much time focusing on it today. And in this interaction model piece, we map the utterance, which is what the user said, to the intent, which is what the user meant. We're going to extract any slots, which are parameters that can capture specific types of information from the utterance, like the time of an appointment or the customer's name. And each bot has one or more intents, and each intent can have 0 or more slots. Both the ASR and the interaction model are using machine learning. And as the bot developer, you provide the configuration for this piece, and you give the training data for the interaction model through sample utterances and slot values. And this piece is really important, and that's why we'll be looking at some good practices around it in a couple of minutes. But before that, let's finish out this flow. So once we've matched an intent and we've captured any slots, we move to fulfillment, which represents the action that we need to take based on what the user meant. And it could just be replying with a simple response, like the times our lines are open. Or there could be a whole architecture underneath here that hooks into our internal platforms or an external system and takes lots of actions, like updating customer details or booking an appointment. And within our bot, we also have our conversational and voice user experience. Yep, there's still design. And just like you wouldn't put out a website without thinking about the colors and the fonts and the layout, you also shouldn't put your bot out without thinking about your user experience. And that includes lots of things, including the actual voice you use, the things it says, the way it handles failures conversationally. And surfacing up all those design decisions is the final piece, the text to speech, again, using machine learning. And as developers, you have a lot of control over each piece of this flow. And we'll be looking at the features you can use to get your ASR tuned to your exact bot and the conversations. But first of all, let's look at that bot recognition of what the user meant, the interaction model. The interaction model is at the heart of the bot. If it isn't solid, then your bot may not have good containment rates, as it won't be able to match what the user said to what they meant. Amazon Lex uses machine learning to be able to understand the conversation, and it does that in two ways within this piece. First of all, when you build a bot, you need to give it all the knowledge it needs about the types of conversations it will support. And you do that by firstly how you configure the bot, so the intents and the slots, the different types of data that you're saying each slot is, what order it should be collected in. And secondly, the training data you give it, so sample utterances and the slot values. And those are also used to tune the ASR model specifically for your bot. So on top of that generalized ASR model, so what you put in there really does matter. And finally, the second piece is that the underlying service will then enrich it with knowledge about language generally. And that will enable it to understand phrases beyond the exact data that you have put into it. So let's look at a quick example that might help you understand how we set up our bot matters. So let's imagine that you have in front of you a table with piles of index cards. And you're handed a new one, and you're asked to decide which pile it should be added to. So I want you all to take a look, and I want you to put a number into the chat of the pile that you would choose if you had to make this decision. And right now you're thinking, I was told there was no interaction, I didn't have to do anything. Well, I'm going to require you to put a number in and say, here's the one I would go with. So it looks like we have a few different numbers coming in. So maybe 3. Have an issue. Maybe 4. Report fraud, could be that. Maybe I see 5, I see 8. Maybe it's 7. Maybe they just want to check their credit. I see number 1 even. So it's not clear. It really isn't clear which one this should go in. And if it's not clear to you, it wouldn't be clear to a chatbot, right? A human is way, way smarter than a chatbot. So if you look at your intents and the things in them and you wouldn't know how to match something to it, I guarantee you your chatbot will not either. Now, you probably applied your human knowledge and you looked at this and you said, okay, this is a bank scenario. But what if you had no context? What if they were just piles of what seemed like random things? That would be even more difficult. How would you even decide how to put it in a particular pile? So we really want to be making sure that we are making things as clear as possible. So let's look at how we would do that in our bot configuration. Well, It's a very high-level list, as Mike said. There is a blog with a much deeper, detailed information and examples that will be linked at the end. But let's just go through a few high-level ones because they are so important. So we definitely wanted to cover them today. So the first is that each intent should represent a single clear concept. So make sure your piles of index cards are easy to match, right? Don't give your bot what appears to be a bunch of random overlapping piles of words. The next is that the data needs to represent the types of things the user will say and give a range of examples of different types of things. You want to try to have at least 15 sample utterances per intent and to try and keep the same number across intents, right? If one intent has 300 and another one has 15, you're probably more likely to be getting hits on the one with 300 than the one with 15. And you want to have lots of variation in your phrasing. So not all just single words or really long sentences. Try and put a mix of different things, short phrases, longer phrases. And again, keep that consistency across all of your different intents. If you have one intent that all is just one words and the rest are mixed, well, now you've kind of biased it to saying, well, if it's just one word, maybe it's this intent because this intent is all one word. So you want to keep that variation of the lengths of phrasing, the type of vocabulary, the punctuation, the way you use your slots. Keep it really mixed within your intent and really consistent across your intents. Next, use slots where you can, but keep each slot to a single clear topic, just like those sets of index cards, right? And you want your slot to be ideally a short noun or adjective phrase. So a list of cities or coffee sizes. Don't use carrier slots like, how should I? I know it can be tempting. You look and you say, I could make these really short by putting all these different phrases like, how should I, how could I, how would I, into a slot, and then I'll only need 3 utterances. But if you do that, you're going to reduce the ability of Amazon Lex to generalize your utterances for you. And you always want to prefer using slots over explicit values. So don't write, city names or other, nouns into your utterances. Pull them out, put them in a slot. Even if you're not capturing them, that's going to help you get better generalized utterances. And make sure that you know about the different options for slots. There is lots of different features available now. There's lots of different types of slots. There's different things you can put on them. Mike is going to cover some of them later. Using the right one is really going to help you get that collection really accurate. And again, we're talking about ASR a lot today, so consider how the words will be transcribed. So for instance, if you have an acronym like ATM, where the user will say letters, then it should be written into your sample utterances as individual letters spaced out. Or an abbreviation like DR for doctor. If you are creating a model for a voice bot, you don't want to put DR in because that is not how the user would say it. You want to put in doctor, which is how the user would pronounce it. Now, if it was for a text bot and people are going to be typing DR, that's perfectly fine. But when you're creating one for voice, you really want to think about how is this going to be transcribed. And finally, if you have a specialist domain, make use of custom vocabularies, which Mike is going to talk a little bit more about. And finally, keep reviewing your bot and updating it. Nobody gets it perfect, first of all, and your customers are going to surprise you with the things they do. And if you expand out to new customer bases, they're going to do completely different things. So always review your bot regularly, make improvements, keep getting better. Now, all of that was focused on build time. So let's take a look at some of the things we can do at runtime to make our bot smarter. In a normal flow, a user will talk to Lex and it will respond without us needing to do anything at runtime. It's going to base all of the decisions on what intent to match, what data to collect, what path it should follow on that configuration that we set up at build time. But we do have the option of intercepting the incoming request and taking a peek at it in Lambda and even changing it. Before Mike shows you examples of that, let's look at the different types of code hooks that we can use to do that and how we set them up within the bot. Because we're going to need to do all of that first before we can take advantage of the features that we're going to be able to enable through that code hook over to our Lambda. And you'll probably be creating your bot through code, but I am going to show you on the console where we connect these things into, because I think it helps set in context where that is, as well as looking at it in the JSON. So firstly, we're going to attach a Lambda to our bot itself. And a Lambda is associated to a particular alias. So here we're going to choose our testbot alias, and then to a particular locale within that alias. So for each alias and each locale within the alias, you need to specifically attach a Lambda. Now these can be exactly the same Lambda, or they can be different Lambdas. But for all intents, within that locale, you will hit the same Lambda. So you need to specifically specify for each locale within each alias. And then once you've done that, everything within that locale and that alias will hit the same Lambda. So here it is programmatically. You would set it up in your create bot alias. There are 3 different types of code hooks within your bot. Each has a slightly different purpose. But again, remember, you're setting up just one Lambda. So each of these 3 different types are going to go to the same Lambda. So let's go through them. The first up is your fulfillment code hook. And it is used to invoke your Lambda at fulfillment and used only within the fulfillment step, right? Really simple. There is only one fulfillment code hook per intent. And here is where it is in the console. So we scroll all the way down to the bottom of all these different steps. And we check that our fulfillment step is active, because if it's not active, we're not going to hit fulfillment at all. And then we go ahead, hop into advanced options, and we're going to make sure that use Lambda is checked. And programmatically, this is set up when you do create intent. And it's just within the fulfillment code hook. And you'll need to mark it both active and enabled on the code hook itself. And this code hook is used for things like taking action based on that data you've collected, or getting answers to your questions, maybe for your FAQ. So you might be reaching out to a search service, or even using your own LLM, or you might be routing onto something else. So for instance, a follow-on intent. The next 2 types of code hooks are called dialogue code hooks. But before we look at them, let's make sure we've enabled our intent to be able to use dialogue code hooks. Because remember, fulfillment code hook and dialogue code hooks are 2 separate things. So right at the very, very bottom, we're going to check this checkbox in the code hooks section. This is really important, right? Programmatically, it's in your create intent. It's at the top level, dialogue code hook. It is a circuit breaker. If it is disabled, no dialogue code hooks will be called. The fulfillment one will be if it's on, but none of your others will be called, even if you have enabled them separately. Once it's enabled, you can turn off some of the separate dialogue code hooks individually, so you can turn them off individually. But once this is off, even if you have enabled them individually, they will not be called. So if you want to call any dialogue code hooks, remember you need to have this on. And if you turn it off, even if you have sent them in as enabled in other places, they're not going to get called. So the next, oh, great. I see a question for what dialogue code hook. So a dialogue code hook is just a call to your Lambda. So the code hooks are the connections between your bot and your Lambda. So the dialogue code hook happens as part of the conversation, as part of the dialogue, and the fulfillment happens in that final step. So here is our next type of code hook. It's our conversational step dialogue hook. And it invokes a Lambda as a step in the conversation. And it can be used between any steps in the conversation, up to fulfillment, where we already had our fulfillment code hook that went out to our Lambda based on a defined flow or conditional logic. So let's look at where we turn that on, and then we will talk about why we might want to use this. So we're turning on here for a slot. You can turn this on in other places. As I say, you can put this between any steps. So you can put it in between your initial response and your slot collection. You can put it in between each slot. You can put it at your confirmation in between it and your fulfillment. And so down at the bottom here in our dialog code hook, we're turning it on. We're making sure it's active. And we're going to set an invocation label. Because let's remember that while there's only one, is everyone having problems with the screen share?
I'm able to see it okay.
Okay. Okay. Sorry, Rajesh. Maybe drop and come back. Perfect. Some people are getting refreshes frequently. Okay. Apologies if you're getting refreshing. Hopefully you're still going to be able to follow okay. We'll go back to the slot validation dialog code hook. And I'll just go back a step. So here we are enabling our dialog code hook. There's only one fulfillment code hook at the very bottom. So when we've completed everything in our intent, but the dialog code hooks can happen multiple times throughout. This particular one happens in between steps. Here we're using it to validate a slot. And because you can call these type of code hooks multiple times throughout, we want to add an invocation label. It is optional, but it's really going to be helpful when you are in your Lambda to know which particular dialog code hook that you are hitting. And this particular one for create slot, it is within our slot capture settings. We just need to make our code hook active and enable our code hook invocation. And the types of things we would use this code hook for is to do things like check the confidence score or transcriptions or sentiment scores. And that would be especially if we're using it at the entry to the intent before we do any data collection. If we want to check something like, well, maybe the confidence is too low and we want to actually go back and re-ask the user. We can put it between slots to validate the slot input. We could even take actions or modify the path of the conversation. And as Mike is going to show you in some of the demos, we can do things like add additional information into the session that we can use throughout the conversation or to do things like help with speech recognition. Our final type of code hook out to our Lambda is an elicitation code hook. And this invokes a Lambda for each thing the user says. And it can be used either within the slot step or within the confirmation step. And here's how you would turn it on at the slot step. So remember, we went into the same place and we turned on the dialog code hook. That was going to happen after we'd collected the slot. But now we're going to go ahead and put on the elicitation code hook, which is called each time the user is prompted, each time the slot is elicited. And again, we're going to remember our invocation label. And this is in that same slot capture settings, but it's called an elicitation code hook. And why would you use this particular type of code hook? Well, you're capturing it each time the user speaks. So you could do something like adjust the response based on the number of retries. So how many times do we have to try and prompt this user for this particular input? We could check transcription scores or options. So when things come in, we can check how confident are we that we've actually heard what the user said, and we can make a different decision depending on that. And we can even change the slot capture types if the user is struggling, like switching to spelling, which Mike is going to do a demo of. So let's look at a simple example to try to understand the difference of all those slot types, because I know they're a little bit confusing to work out, okay, why do we have different types of dialog code hook? So here we're going to have a customer trying to order a latte, and we're going to match our get coffee intent. And we really want to capture the size, but the customer really needs a coffee, and they're going to give us a response that we do not have in our list of values. So we're going to reprompt them again, and we're going to say, what size do you want again? And we're finally going to get an answer that is in our list. So we're going to head out to our fulfillment, and we're going to make that coffee. So let's add a fulfillment code hook so that we can actually take that action, because that customer really needs the coffee. But let's also add in a conversational step dialog code hook to do the validation. So after we've successfully captured the slot, let's go out and check that the size is one we offer for that particular type of coffee. So we may have a small, medium, and large latte, but perhaps we only have one size for a flat white. But you also saw that the customer was struggling, and we only got to the validation code hook once we'd successfully captured the size. So if we wanted to get insight into every step, we would need to also turn on our elicitation code hook. And then we would call out to the Lambda for each step of what the customer said. Now, you may be looking at this and saying, well, for that successful value at the end, the large, we called the elicitation dialog code hook and the validation code hook. So do we really need them both? Well, the answer to that is, as always, it depends. But let's consider this following solution, right? So if the customer said, I'd like to order a large latte, then when we move to the slot elicitation, so we're like, hey, we need to capture the size, we will check and we will already have the size, and we will not prompt for it. And so we will move straight out into the success path and into the validation Lambda. And then we'll finally go to the fulfillment step. And so we have now not hit any elicitation code hooks because those happen within that slot. The user was never prompted. They gave it in their first utterance. So if you were trying to use those to take an action, in this case, you would never have hit them. So make sure that you're using the right type of code hook for what you need. And also make sure you aren't using code hooks where you don't need them, so you're not making any unnecessary calls out to Lambda. So before I hand over to Mike, let's get you a quick look into all of the information that when your bot passes over to your Lambda that you're going to see, because that's all the information you're going to be able to use to do all your cool things. And when I hand over to Mike, he's going to show us doing those cool things. So remember, we only have one Lambda, and all of these different types of code hooks are all going to go into that one Lambda. And each of them are going to send in an event in the same structure, although not all fields will appear each time. The very first one here I'm going to call out is the bot. So this is details of the bot that it came from. So for instance, the name, the version, the alias. Remember, you can use that same Lambda for as many aliases or as many bots as you like. So knowing that can be useful even for tracking and troubleshooting later on. The next is the session ID, so that you know what conversation this is part of. The request attributes give details for that specific request. So for instance, you'll see when a request comes in from Amazon Connect, in the request attributes, you will see details identifying it as coming from Connect. The input mode tells us what modality it was sent in, voice or text. Remember that everything is going to be text when it comes into our Lambda. So it's really important that we know, is this a voice originating, so that actually we need to think about the transcription, or was this text from a chat? And the response content type says, hey, here is the type of modality I would like this back in. Please send it to me in text, or please send it to me in audio. And the invocation source will either be fulfillment or dialog code hook. And that invocation label, if you set it, will let you differentiate those different dialog code hooks. And if the input was voice, you may see some different options here in the transcriptions. So you'll see in the demo later on what that might look like. So, some words kind of sound the same. And so you could have a list here of things like, it could have been these things, and here is my confidence. And that can be really helpful. So for instance, if the confidence score for all of these was really low, then we might be having a problem hearing the customer and not a problem understanding what they're saying and matching it to an intent. And in that case, you may want to change your response to the customer. So you probably don't want to say, can you rephrase that? If the problem is an audio one, you might want to say something like, can you move to a quieter location? We're having trouble hearing you. Or if you look at those transcriptions and you have outside knowledge for what you expect to be in there, you might want to check a couple of the high confidence ones and choose a different one that has been selected. The interpretations, like the transcriptions, is going to give you some options for other matches. So in this case, it's going to be the intent matches. So again, those are going to come in with confidence scores, and you can make a decision if there was two that were very close. Maybe you want to use a different one, or maybe you want to go back and check again with the users. So that's going to give you real insight into what the Lex service has selected and the other options it could have selected. The session state tells you exactly what the Lex service has selected in that moment, what it believes about where we are at, and we'll dive into that in a moment. And finally, the proposed next state is the details of the next state that Lex plans to move to based on the bot configuration. And this is for runtime hints, so that you know when you're going to move to that slot, and you can go ahead and add them into the session at that point. And because this is about the next step and slot fills, you're not going to see that on fulfillment. You're only going to see that as you go through. And we can use all of this information to take actions. So for example, order that coffee or change what happens next. So how would we make that change? Well, we would do that through our response. And this is a much smaller set of fields than you just saw in the request. Again, we have those request attributes. Normally people just return what was sent in. We have a messages section. Those override what the bot was going to say based on the configuration and lets us control that completely, so we can change the next message to the user. And the session state, it can just be what Lex passed to us, or we can change it. So let's jump into that. First up in that session state object, we have the dialogue action. And it represents not those messages, so not the words we're going to say back, but the type of response we're doing. So for instance, the first up here is close. That ends the conversation. Ideally, make sure the customer is in agreement about that. Don't just walk away mid-conversation from them. Or we can confirm intent. So we can confirm with the user that they want us to go ahead and take the actions that we're planning to take. Delegate says, hey Lex, whatever you have in your configuration that we set up at build time that you think is the next step, you go on ahead and take it. So it delegates back to Lex to decide what to do next rather than you explicitly telling it. Elicit intent puts us back to trying to match the intent based on the next thing the user says. So for instance, we've mentioned confidence scores in the interpretations. So if they were too close, we might want to push it back and say, right, let's ask the user again what they would like. Or if we've completed one intent, we may want to say, hey, is there anything else we can do for you? And finally, elicit slot. And this is where we prompt for a slot value. And when we do this type, we supply the slot we want to prompt for. And we also supply how we want to capture that. So you see we've got spelling styles in there as well, which we're going to look at very soon. Next is the current value for intents and slots. Remember, we can change this here. So perhaps based on those various transcription options or things we know outside of the bot. The active context puts restrictions on what can be matched next. So for instance, only allowing certain intents to be called if another one has been completed before it, and allows passing of data from one to the next in that case. The session attributes allows us to keep values through the whole conversation. And as well as using those session attributes at runtime as we go along, we can actually have set up a build configuration to be able to use some of the session attributes. So for instance, within conditional flows or within particular prompts, we can go ahead and say, if these session attributes appear, you can use them. And finally, those runtime hints, which are suggestions for what the user is most likely to say next. And we're going to have a demo of that. So with this little JSON structure, we can take really powerful actions to take advantage of some of the really advanced features Lex has available, all during our runtime. And Mike is going to show you that now. He's going to jump in and do some various demos for how we can sort of leverage some of those features, both that you can set up at build time and also that you can take advantage of at runtime.
All right, thanks, Gillian. And let me get my slides up here. If I can find my mouse, that would be helpful. There we go. All right. Let me know when that's up, Gillian or Alex, if you could.
I can see it.
Perfect. Cool. So like Gillian mentioned, we're going to be covering 3 features that were released in 2022 within Amazon Lex that help you enhance your bot's ASR efficacy rate. These are all features that we've heard the demand from customers, and today are thrilled that we're able to provide those to our customers, and they're seeing success with them today. Those 3 ASR capability features that we're going to be talking through are going to be custom vocabulary, spelling style, so both spell by letter and spell by word, as well as runtime hints. We're going to use the remainder of the time today to talk through these and to show some live demos. Unfortunately, we're not going to make this an interactive building session today, but as I just mentioned in the chat to someone who asked the question, we will be providing a Lex self-service, public free, all the good stuff workshop that'll let you kind of walk through at your own pace and kind of build a scenario similar to the one that I'm going to be demoing. So the first one here that we're going to talk through today. Just a little background. Lex uses a language model to determine transcriptions from audio utterances. Some customers have told us that they've had problems where they're trying to elicit for industry terms or acronyms or things of that nature. So obviously industries have specific terms, phrases, acronyms, brands, proper nouns, products, all of those things that might be real words, but it might not be weighted as heavily within the generic language model. And that can result in some missed utterances or slot values. So by using custom vocabulary, you're able to specify those terms, phrases, acronyms, etc., and reduce the missed utterances and mistranscriptions of those vocabulary words. How this works is that you will assign a word you will have a word and you will assign a weight to that word from 0 to 3. I'm going to talk about 0 here in a second, but from the weighting perspective, 1 is going to be the lowest and 3 is going to be the highest. And this number will be based on how often those terms are misrecognized, right? So it's just kind of a tuning exercise of making sure that your vocabulary words are getting recognized. And if one particular word is not, maybe we want to increase the weight of that word. And then I did say it's from 0 to 3, right? So 0 actually infers that it's not weighted any higher than any other word in the generic model. But what 0 can be used for still is for things like acronyms. So if you had a scenario where your customers, for instance, if you're a financial services organization, if your customers are saying PMI, meaning private mortgage insurance, you can use custom vocabularies to correctly transcribe that acronym, but also to translate that to the full non-acronymized, the full length phrase of private mortgage insurance. Customer vocabulary, like Gillian mentioned, is built at build time and can be applied to either the language or slot level, which we'll walk through. And then just some use cases on the right-hand side here. So some industry terms from, let me get my little handy laser pointer here. Yep. Some industry terms. So things like tax forms, right? 401k, W4, 1040 ES. There's a ton of other ones as well. But kind of atypical kind of terms that may be only applicable to tax or financial services industries. Same thing with company name. So, if your company name isn't an English word per se, and might be a culmination of English words, or simply just isn't getting recognized or the weight that you need it to be recognized, you can specify company names and other proper nouns as well. Domain-specific terms we talked about, acronyms we talked about. So the examples I have here is PMI, private mortgage insurance, or HELOC, home equity line of credit. So let's take a look at what an actual flow with custom vocabulary looks like before and after we enable it. So on the left-hand side, we have the dialogue and our bot saying, hi, Sammy, how can I help you today? And Sammy wants to check the balance of her HELOC account. So the bot is going to hear the utterance HELOC up here. And the ASR is going to do its best to try to transcribe that, and it might not know that acronym, right? And in this case, it doesn't. So it actually transcribes it to HELOC. These transcriptions will vary based on how the customer says the word and things like that. HELOC was the funniest transcription that I got from it, so that's the one I decided to include. And then, so if we were to go and use custom vocabulary, well, let me back up one. So if ASR transcribes the utterance to HELOC, the NLU model and the interaction model aren't really going to know what to do with that. So the result of that is going to be reprompting and hoping that the customer, rephrases what they're saying or changes what they're saying altogether, which is obviously not an ideal customer experience. So this time we're actually going to use a custom vocabulary as part of the slot. So the slot is going to be the account type. So account types can be, checking, savings, line of credit, things like that. So I'm actually going to add HELOC as a custom vocabulary within that slot. And then the next time that the customer comes in and says, I want to check the balance of my HELOC account, the ASR is going to be able to accurately transcribe that and fulfill the intent for that customer. So let's go through a quick demo of how we can leverage custom vocabulary here. And let's see. Great. And just be patient with me. I'm using a trackpad on a giant monitor in the room here, so it's going to take me a couple seconds. So just to get everybody familiar with the bot, it's very basic bot. We have two intents. We have transfer funds and we have change email address. The transfer funds intent is what we're going to be looking at for this particular demo. And I'll scroll down here and show you a little bit of just housekeeping. Here's some sample utterances of the bot. So, I want to transfer funds, switch money. I want to transfer money from account in my to account. We'll talk about the slots here in a second. And then there's an amount as well. So how much money do you want to transfer from one account to the other? So I'll scroll down here to slots. And you'll notice there is a fourth slot. This one is actually not going to be required this time around. When we talk about runtime hints, we're going to bring this back. We're going to come back to this intent and make some modifications to our bot, including mother's maiden name. But for our custom vocabulary demo, we're just going to be using the from slot, or the from account slot, the to account slot, and the amount slot. The from account and to account slots are both of a custom slot type called account type, which I'm going to cover right after I get done with this intent. And then the amount is just going to be Amazon.number. So we're just trying to collect a value from the customer, a dollar amount value. From there, we're going to confirm with the customer. So you want to transfer X amount from account Y to account Z. Yes. Okay, great. And then we'll go through the fulfillment, which is just going to kind of give us a message of great, you've transferred successfully. So let me move back to the slot types. So I mentioned that the account type slot type is a custom slot. So you see custom over here. I'm going to go ahead and click into it. And we're going to see that checking, savings, and line of credit are our three account type, valid account type values. On the right-hand side here, I've also added a credit account. So this is just kind of a synonym for line of credit. So if somebody were to say, to transfer my savings to my credit account, we'll recognize that as line of credit. One thing that you won't see on here is HELOC. So again, that home equity line of credit slot value, and that's what we're going to be using today. So I'm going to be calling in, and I'm going to be asking for to transfer, from my savings account to my HELOC account. And the bot is not expected to know that, right? That is an industry abbreviation, and it's going to fail and reprompt for, sorry, I didn't get that. Let's try a different account or something along those lines. So let me go ahead and call in.
Hi, Mike. Thanks for calling Acme Bank. How can I help you today?
I want to transfer funds.
I'd be happy to help you transfer funds. What account would you like to transfer funds from?
Savings.
And what account would you like to transfer funds to?
My HELOC account.
How much money would you like to transfer?
$300.
Okay. So you want to transfer $300 from your savings account to your line of credit. Should I execute?
Yes.
Okay. Great.
Okay, so in that example, it was actually grabbing it. Love live demos, but hey, that's a learning opportunity. So let's dive in and see exactly what happened there. So I'm going to take a look at my Lex logs, and it could be very well that it's on a different bot alias, but let's double check here. So okay. Oh, this is the wrong elicit, so let's go up one. Okay, that's our confirmation. $300, that's our amount. So this one should be okay. It seemed like it heard credit account that time around. Let's that's interesting. I don't know if I said that or or if it picked it up wrong. Let's see.
Hi, Mike. Thanks for calling Acme Bank. How can I help you today?
I want to transfer funds.
Sure, I can help you transfer funds. What account would you like to transfer funds from?
My HELOC account?
What account would you like to transfer funds from?
Okay, so in that example, it asked me what account would I like to transfer funds from. I said HELOC account. We didn't have a great retry prompt there. My retry logic was on the to account, but we just got reprompted, right? So it's saying, just rephrasing, what account do you want to transfer from? So this time around, we're going to add HELOC as part of our slot values. And then we're also going to click this box at the very bottom that says use slot values as custom vocabulary. We're going to go ahead and, sorry, the little pop-up here is in my view, so I can't see the save button. Give me 1 second. There we go. So I can click this save at the very bottom. So I've saved my slot. I still have to build my bot. So anybody that's built with Lex, you're obviously having to build the bot. And this is really compiling your machine learning model within Lex, right? So both the ASR and the NLU are being compiled right now. Depending on how complex your bot is, usually takes 10 seconds or so. But we should see this finish up here pretty quickly, and this bar will turn green when that happens. Great, so we've built our bot now. So there's one other thing that we need to do here. Well, there's two other things. So first, we're going to create a new bot version. So I've just created a new build of my bot, and now I want to put it into a production scenario. So I'm going to version this. Maybe I'll put a description in here saying added HELOC to custom vocab. And I'll go ahead and create. And then my alias, so my Amazon Connect account is actually using the alias of dev. So I'm going to go ahead and click into dev here. And currently, dev is pointed to version 18 of my bot. So I'm going to change that to the version we just created, which is version 19. Go ahead and associate that, and let me call in again and see how our experience has changed.
Hi, Mike. Thanks for calling Acme Bank. How can I help you today?
I want to transfer funds.
I'd be happy to help you transfer funds. What account would you like to transfer funds from?
Savings.
And what account would you like to transfer funds to?
HELOC.
How much money would you like to transfer?
$300.
Okay. So you want to transfer $300 from your savings account to your line of credit. Should I execute that request?
Yes.
Great. I've successfully executed the transfer. How else can I help you today?
Great. So you see that time, and I guess I'll show the transcriptions here so that we can see that it is actually recognizing HELOC, because we kind of had a false positive at the beginning here. And we might have to open up a new stream. Yeah. Let me scroll to the top here. Open up our latest log stream. Make sure that's the one that we want. 1254. That sounds right. All right. Now let's take a look. So you see, and this isn't the specific elicitation slot or elicitation code hook, but this is actually these are our conversation logs. So this is not using any Lambda code hooks, so it'll be in our next demo. But our slot values here, you see that the original value is HELOC, and that we've resolved that value to line of credit, right? So remember, as we went back to our slot type, our account type, we said, hey, if we hear HELOC, we actually want to kind of resolve that to line of credit. Great. So I'm going to go back to our slides here and kind of go through another ASR functionality, our next ASR functionality, which is going to be spell by. Once I get control of this mouse. And then Alex or Gillian, any comments on the audio quality? Was everybody able to hear my call in there?
Sounds
The
good.
audio is, yeah, audio is good to me.
Perfect. Okay. So the next challenge here is in the IVR. Sometimes it can be difficult to caption certain slot values like names, street names, email addresses, things like that. And these are all slot types that have a level of ambiguity with them, right? So for names, as example, you can spell Sean, S-H-A-W-N, S-E-A-N, S-C-H-A-U-N. You can spell Wolf, W-O-L-F, W-U-L-F, W-O-L-F-E, in more last name or potentially street name scenarios. Or, there's just names that sound really similar, right? So there's Abby and Gabby or Amanda and Miranda. Those are types of slots that can be difficult to get a good accuracy within the transcription through ASR. It also can be difficult to capture things like alphanumeric or names or street names when the letters can sound similar, like P, B, and T or M and N. That's Paul, Bravo, and Tango, and Michael and Nolan. If you couldn't get if you couldn't tell the difference between this in this audio. And also, confirmation codes and record locators. Like if you had a record locator of J1PBT42, that's going to be difficult to understand, not only at a human level potentially, but also would be even more difficult to understand with an IVR. Like I mentioned, you may be able to hear it from on this recording, or you might be able to hear it talking to a person in face to face, but it's not going to be the same audio quality as telephony networks, right? So the telephony networks use 8 kilohertz audio, which can make it difficult to determine. And a lot of the times that's why if you're on a phone and you're on with an agent, and they might kind of read things back to you and use phonetic alphabets and things like that to ensure that you're communicating effectively on that medium. So two different kind of spelling styles that we've introduced to help with those problems. The first is spell by letter. And this really allows a customer to spell out slot values with ambiguity, like names, street names, email addresses, by letter, as the name might suggest. So if I were to elicit for an email address, if my email is miknolan123@gmail.com, I might say, micknolan123@gmail.com. And the transcription might read that as micknolan123@gmail.com. Whereas if I'm going to spell it out, I can spell it, micknolan123@gmail.com. And we can get the more accuracy through actually spelling it, especially when there's that ambiguity of email addresses and of the like. There's also spell by word, so you can also instruct your bot to spell to listen for spelling by words of letters. So maybe it's a record locator again, and I think the one I used before is J1PBT42. You might instruct a customer to read that as J1, P as in Paul, B as in Bravo, T as in Tango, 42, and be able to more accurately get that record locator on the first try. And that's largely how humans communicate too, right? Especially over telephony networks, where you can't see the person, you don't have other context clues like their mouth movement, things like that. Spelling styles are used at runtime, and this allows you to determine if the customer is struggling and pivot to a spelling style. So these are particularly good for retries. So if we don't get it the first time, let's have them spell it out. But it also has good use cases for alphanumerics, like I just mentioned, like record locators. Maybe I just want to start off with a spelling style and have them kind of read that to me and get that accuracy enhancement on the first try. In the vein of hyper personalization, you can also look at the customer experience holistically, and if they're having trouble being understood by the ASR, maybe they have maybe they're in a loud place or something, you may want to default to spelling styles for some slots. Another example of that is maybe you want it to be the default for customers that might have speech impediments or speaking disabilities. So there's a lot of different flexibility in how you can leverage these speaking styles because they are at runtime, and you can use them at will. So let's take a look at how this works in an example flow here. So on the left-hand side, we have the conversation. So, hi, Mike, how can I help you today? Hi, I'd like to change my email on file. Sure, I'd be happy to help you with that. What would you like as set as your email? And the utterance might be, this is the email. So as a customer, maybe I'm going to read this as micknolan123@gmail.com. And the bot might transcribe to something like this, right? So micknolan123@gmail.com. Well, no, that's not quite what I meant. So when the bot comes back and confirms, I'm going to say no, like that's not how I spell it. And as a retry, what we can do is we can use the elicitation style of spell by letter. So in our response back to our customer, maybe we say something along the lines of, sorry, I didn't get that the first try. This time, let's try to spell it out letter by letter. And the customer could say, micknolan123@gmail.com. And the bot can successfully transcribe that then. One thing I do like to point out here, spell by letter doesn't necessarily mean you have to spell out absolutely everything, right? So we're eliciting for an email response, and I don't say ATGMAILDOTCOM, right? That would not be a great customer experience. So just know that we're not forcing you to spell everything out, and I've found that this working very, very well. So let's take a quick peek under the hood then, and take a look at how this dialogue was going to flow, and how we can invoke AWS Lambdas to elicit for a specific spelling style. So the conversation, again, how can I help you today? I'd like to change my email on file. Sure, what would you like to change your email to? And again, we say micknolan123@gmail.com. So and the bot responds to it back and spells it out for us. So if that's micknolan123@gmail.com, correct? No, that's not right. Okay, well, this time we want to elicit the same email slot again, but we want to have the customer spell out their email address because we weren't able to get it the first time and how they pronounced it. So Lex is going to call AWS Lambda with a code hook. And Lambda is going to respond with the slot to elicit and the elicitation style. So this isn't the exact payload that Gillian went over. We're gonna take a peek at that in our Lambda logs when we look at that. But just for simplicity's purposes, I didn't include that here. And then finally, we respond to the customer and change the prompt to say, let's try that again. This time, please spell out your name. Spell out your email address like JOE@gmail.com. So then hopefully the second time around, the customer can spell out their email address and we can fulfill that or capture that slot. All right, let's take a quick peek at a demo here. So the first thing I want to show, really struggling with this mouse today, apologies. First thing I want to show here in the intents is this change email intent. So this is the intent that we're going to be using for spell by letter. For our prompts here, I need to change my email address, email on file, or our utterances, sorry, change web address, change email address, etc. And then I am using Lambda within this utterance or within this intent. And I'm using it, I think at the very end as a validation. Yep, so I'm using the code hook for validation down here. And what this is going to allow me to do is leverage the Lambda function for two different things. First of all, my prompts are stored in my Lambda in this scenario, along with the spelling style that I want to elicit for them. So right now it's just going to be default, which I'll show you in the code here in a second. And then the other thing that I'm using Lambda for is converting the email address into a string that the customer will be able to hear, right? So I add some breaks in there, so it reads it out really nice to the customer. Okay, so your email address is MIKNOLAN, which kind of reduces the cognitive load on the customer, and they're able to follow along with that. So I'll pick up some of the code here and throw that over on the shared slide. And the code, so in my change email address intent, I've got my handler and my prompts. If I click onto my prompts, you'll see these are the prompts that I'm going to be using. So when I elicit email address, let me scroll up here so you can see that this is for eliciting an email address. The first one I'm going to ask is, what would you like to change your email address to? And then my elicitation style here is going to be default. Message type is plain text. I'm not using SSML in this example, so that's fine. Our second prompt, okay, let's try again. What is your email address? Again, we're using the default, so I'm going to call in first and kind of have that negative experience similar to how we did custom vocabulary, and then make some changes, push some code, and see how that manipulates our customer experience. And then the only other thing down here I wanted to point out is confirmation. So again, I mentioned that I'm using a Lambda function to kind of compile a string that can be easily read from to a customer. So I am using SSML in this instance, and then I'm taking this string and doing a string replace on this email address based on the slot that I get from the email slot that I get from the customer, and breaking that out into, well, let's stop talking about it and start showing it, right? Let's see, where is that? Change email address. Okay, so it's this last function in here. Get email confirmation prompt. So taking the email, splitting it out character by character, and then inserting an SSML break in there so we can read it nice and easily to the customer. Cool. So this time around, again, we are just listening for an email address. It's not going to be listening for spelling. So I'm going to call in and we can see what that experience looks like.
Hi, Mike. Thanks for calling Acme Bank. How can I help you today?
I want to change my email.
What would you like to change your email address to?
micknolan123@gmail.com.
Okay, so that's in ICKNOLAN123@gmail.com, correct?
No.
Okay, so that's in ICKN.
So we called in and we had the the bot do its best to elicit a spelling slot, or to elicit the slot for email. I said Mick Nolan. It actually heard Nick, as in Nick, Nolan123@gmail.com. So the next time here, we're actually going to want to change this so we are. Oh, there we go. We're using the spell by letter spelling type. And a couple of housekeeping things here. First, this is just a JSON blob and how I'm storing my prompts. Certainly this can come from a database, but this is being used in my response payload from this Lambda function. So it's not the response payload in its entirety, but it is the response payload. It is being used within the response payload. So I switched the spelling styles for that to spell by letter. And then I also want to prompt the user to spell, right? So if I just say, let's try that again, what's your email address? They don't have a context clue to spell it. So in this example, I'm going to say, this time, please spell out your email address letter by letter. I'll do the same for the one below that. And I will save. Cool. So I'm going to push this code up to using CDK. So for those of you not familiar with CDK, it is a infrastructure as code tool that I can simply run that command, and now it's pushing all that code to my Lambda function that is running in AWS. So once that finishes, I can call in again and see what my experience is like. Were there any questions in chat, Alex or Gillian?
There are a number, but I think we'll take them after this because some of them are a bit more detailed.
Sounds good. Great, so that code has been deployed now. So I'm going to go ahead and call in again.
Hi, Mike. Thanks for calling Acme Bank. How can I help you today?
I want to change my email address.
What would you like to change your email address to?
micknolan123@gmail.com.
Okay, so that's MAKENO123@gmail.com, correct?
No.
Okay, let's try again. This time, please spell out your email letter by letter.
MIKNOLAN123@gmail.com.
Okay, so that's MIKNOLAN123@gmail.com, correct?
No.
Sorry. Let's try one more time. Please spell your email letter by letter.
MIKNOLAN123@gmail.com.
Okay, so that's MIKNOLAN123@gmail.com, correct?
Yes.
Okay, so that's
So we were able to elicit for that spelling style in that. So first it translated to make Nolan 123. It asked me to spell it out, and I spelled it out as MIKNOLAN 123, and that actually also didn't get recognized properly, right? So that might be an example. If you have a lot of data like that, it might be a good example of, hey, maybe I should be using spell by word instead of spell by letter in this example. But I was able to, that third time, kind of pronunciate a little bit more and make sure that I'm pronunciating my A's as you should, and I was able to detect that time. And then we can take a peek at the Lambda logs here. Let me get the latest stream. All right, so if we scroll up here, so here's that original value of me spelling it by letter, 123@gmail.com, and it resolved it to my proper email address. Just FYI, this isn't my real email address. I did reserve this on Gmail so nobody gets spam, but please don't email this. Here's an example of the SSML that I used for the confirmation prompt, right? So, okay, so that's M, and then there's a pause, I, pause, K, pause, etc. And then at the end, I do, at the domain. Great. Okay, let's move on to our final ASR feature here called runtime hints. The problem that customers were facing before runtime hints, sometimes you need to elicit a slot from a customer, either picking between values. So, in a FinServ example, we saw, what account are you talking about, checking, savings, HELOC, etc. In an airline example, maybe it's you're calling in and you've authenticated and they know who you are. And the IVR says, I see you have 3 upcoming trips. What is the destination city you're wanting to modify your itinerary on, right? A language model, even with Amazon.cities, is going to be listening for all the cities in the world, right? Which can cause some ambiguity within that. Same thing for verifying information. So information that you know about the customer, maybe you're just wanting to verify, the mother's maiden name, or maybe you're Amazon.com and you have 2 delivery addresses with us, one in Chicago and one in Seattle. Which property would you like to send your order to, right? So in that example, I want to use the city slot because it could be any city in the world for your customer base. But I know for this customer, they have 2 properties in 2 different cities, one in Chicago and one in Seattle. So how do I get the greatest accuracy out of my ASR in those scenarios? And runtime hints allows you to do that. So at runtime, it allows you to provide slot values when you're expecting, and eliciting a slot to a customer. So those values that you're expecting can be from the interaction thus far. So maybe you've already had the customer in the IVR for a minute or 2, and you've collected some data, and based on the conversation they're either going to choose value A or value B. You can add those as runtime hints, or it's data you already know about your customer in your internal system. So things like your delivery addresses, or your mother's maiden name, or things of that nature. I kind of already gone through the city example here and last name example. The supported Lex types here. You can use custom slot types, like our account type, or you can use city, country, first name, last name, state, or street with runtime hints. Let's take a peek at how this works in a flow here. So just like before, on the left-hand side, we say, "Hi, Sammy. How can I help you today? I'd like to transfer funds from my checking to my savings account." Great, I'd be happy to help you with that. Before you do, though, we want to just verify, we're still talking to who we authenticated before. So we're just going to have, a quick verification step of mother's maiden name. And the customer's maiden name happens to be Wolf with an E, right? So the customer is going to say Wolf with an E. The ASR is going to say, I know how to spell Wolf. It's this. And then we're going to take a look at that in validation. And we're going to say, hey, let me get my little handy laser pointer here. This string does not match this string, so we are not going to validate this, and we're going to reprompt for the customer's mother's maiden name again. Now, one thing I'll say here is you could probably do something with fuzzy logic and things like that to, make this utterance essentially match with this utterance in your code. But with runtime hints, you're kind of putting the onus of that on your bot. So if I put wolf as a runtime hint in my bot when I'm eliciting for the mother's maiden name, it's going to teach the bot to listen for wolf in this type of spelling. So if the customer were to say wolf again, what the transcription is going to be is the proper spelling here. So I have one more example of this that I'm going to walk through, but before that, let's take a look at what's happening behind the scenes here. So again, we have some dialogue. Hi, Sammy, how can I help you today? I want to transfer funds from my checking to my savings account. And from that, we are going to use a code hook on the initialization part of the interaction model to invoke a Lambda function. That Lambda function is going to take this is very similar to what we did on the speaking styles, right? So we have a Lambda function, except this time we're going to reach out to a data store and query customer data and retrieve that mother's maiden name. I'm using DynamoDB in this scenario. Don't get hung up on that. That can be an API, that could be an on-premise database, that could be a DynamoDB table, an RDS table, really anything that a Lambda can access. So don't get wrapped around the axle on that. And then our Lambda function is going to, in our response payload, have the slot to elicit and the runtime hints associated with that. And then we go back to the customer and say, sure, I'd be happy to help you with that. Before you do, can you please verify your mother's maiden name? They'll say wolf. We'll recognize it with the E at the end. We'll validate that in the back end. We'll see that it matches, and we're going to allow that transaction to go through. Another example here, so I mentioned before on kind of airlines, right? So if I call into an airline experience, there's a couple different customer scenarios you can have there. You can say, what is your flight confirmation code for that? Well, guess what? Nobody's going to have flight confirmation codes. So off the top of their head. So a better solution to that would be, okay, I know that you're going to destination cities. I know that you have 4 flights booked, and I know that one's going to be Chicago, Seattle, London, and Barra. And I'm adding these all in runtime hints when I'm asking what itinerary they want to modify here. In Chicago, Seattle, London, honestly, I don't think you'd have any problems just without runtime hints and just eliciting for a city. Those are major cities. However, Barra, I purposely picked out. That is the 4th smallest airport in the world. It's 4th smallest airport city name in the world. And that might not come up every time, right? So we want to train our bot to say, hey, these are the values that we're expecting. So that when I want to change my itinerary in Barra, Rio de Janeiro, I can say, Barra, and we can capture that intent properly and, move on to what the customer wants to modify with that itinerary. Right. Okay, so let's move on to our final demo here, runtime hints. All right, so I'm going to go back to, this arrow is tough today. I'm going to go back to my Lex bot. I'm going to go to my transfer funds intent. And remember before we had the mother's maiden name. So we're going to actually bring that into the conversation and add that as a verification step before we execute the transaction here. So the first thing that we're going to do is we're going to enable the dialog code hook within the initiation. And why we're doing this is because this is the first code hook that's going to be hit within, once I recognize my slot, or intent, I'm sorry. Once I recognize my intent, it's going to come in here. And then the next thing we want to gather is the mother's maiden name. And I'm invoking a Lambda function here so that I can programmatically elicit for this slot and specify the runtime hints, right? So this is going, after this step, it's going to be going to Lambda, and then Lambda is going to say, okay, next step should be elicitation of mother's maiden name, and here is the runtime hint that I'm expecting. So I'm going to go ahead and click require mother's maiden name. I'm going to go into our advanced settings here, and I'm going to enable my dialog code hook. Make sure that that invoke Lambda function is on. And what this code hook is going to do is it's going to work as a validation step. So I've successfully captured a slot. I don't know if that's an accurate slot or not, right? If somebody could have said, you know, Smith, and while that's a valid last name, and we've technically captured the last name, the mother's maiden name slot, it's not accurate. So we want to elicit for that again. So we're going to use a Lambda function to check that logic as part of that flow. And at the very bottom here, we'll also check this, use the Lambda function for initialization and validation to make sure our validations get called. And I'll go ahead and save. Once I save, I obviously then have to build the bot. So I'll go ahead and kick off that build. And while that's building, I'm going to go over to my bot version. So as soon as it finishes building, I can create a new bot version out of this, which I can then assign to the dev alias. So one quick thing here. We're not using runtime hints yet. We're going to look at the code and modify the code here in a second. But we are now involving mother's maiden name within the intent fulfillment, right? So mother's maiden name is now required as part of the intent fulfillment. So I should be prompted for that. All right, we're done here. Let me just put a quick description in here. Add a mother's maiden name as required for transfer funds. We'll go ahead and create that version. By the time I get to my dev alias, that'll be created, which it just finished. And lucky number 20 will associate with that. And let's go ahead and call in and see how our customer experience has changed for a transfer funds intent.
Hi, Mike. Thanks for calling Acme Bank. How can I help you today?
I want to transfer funds.
Sure, I can help you transfer funds. Before I can transfer funds, for verification purposes, what is your mother's maiden name?
Wolf.
Sorry, that's not matching our records. Let's try again. What is your mother's maiden name?
Wolf.
That still does not match our records.
So I think you get the point there. I called in, I said Wolf, and we weren't able to recognize it. Let's take a look at what the transcriptions say. Oh, we got a new stream, it looks like. So let me come up here. Oh no. Most recent. Thank you. Cool. So let's take a look. So it looks like the transcription is going to be WULF. Let me see the actual. Yeah, so here's our transcription is WULF. And maybe that because I was eliciting for a last name, maybe WULF is a more common last name than WOLF, right? So it transcribed it to WULF. However, my maiden name is WOLFE. Also, asterisk, not really. Please don't try to hack my stuff. That is not accurate. But in this instance, we still need the bot to recognize that, right? So let's take a peek at the code. And we're going to go to transfer funds in my handler. So if we're looking through this, let me blow this up. Ooh, let me try to blow this up. Okay. Try to blow this up a bit. And let's take a look at where we are eliciting for the mother's maiden name, right? So this is a function. The stuff ahead is more orchestration level stuff. So I kind of cut that out to keep this as simple as possible. I've built some functions around eliciting slots with retries that keep track of the number of times that we've elicited for a slot. So if we want to do 3 and give up or 2 or give up, that can all be configurable. And we're loading the actual mother's maiden name. So if I go down to this function here, you can see that I'm calling a DynamoDB table. Oh, that's validate, sorry. Get mother's maiden name. I'm calling a DynamoDB table here with the customer phone number that I have. This can obviously be customer number or what have you, any other piece of identifiable information from the customer. Getting the result and getting that mother's maiden name. So if I come back up here where this was called, so again, line 75 is where I'm calling that function that reaches out to that database. I'm retrieving the actual mother's maiden name. I'm setting that as a session attribute for later. And then I'm returning the response. So I'm not adding it as a runtime hint yet. So now what I'm going to do is I'm actually going to uncomment this area here. And what this is doing is, if you take a look, is it's actually adding runtime hints. So I'm creating the structure of it here, and then I'm setting my slot hints for, this should be, this is my intent. And then specifically for my slot mother's maiden name, I'm adding runtime hint value as WOLFE. So I'll go ahead and save that and kick that off. And then this usually takes about 30 seconds or so. But after this does deploy, I will call back in and see how our experience has changed. The one thing I do want to point out here is you'll notice that I'm deploying code, but I didn't, I did make a modification to the bot and I've already deployed that, but I don't need to make another modification to the bot, right? Because it's all just being handled within Lambda, similarly to how spelling style worked. So we're now fully deployed here, and I'm going to call in again.
Hi, Mike. Thanks for calling Acme Bank. How can I help you today?
I want to transfer funds.
Sure, I can help you transfer funds. Before I can transfer funds, for verification purposes, what is your mother's maiden name?
Wolf.
What account would you like to transfer funds from?
Savings.
And what account would you like to transfer funds to?
Checking.
How much money would you like to transfer?
$300.
Okay. So you want to transfer $300 from your savings account to your checking.
Yes.
Should I execute that request?
Yes. Okay. And we'll hang up there for the sake of time here. So That time I was able to call in. I didn't say wolf any differently. I didn't say wolfie or anything like that. I said it how you would say it in plain English. And this time around, I don't know that these are the latest logs. Let me take a look at the timestamp here before we start peeking at them. No, so this is the last time. So let me get the new log stream here. Huh. Still not coming up. Let me. Huh. So I can't find it in the CloudWatch logs right now. I'll have to take a peek at that later. But if we look at the Lambda logs, I usually log the responses. So we can take a peek at how our response payload has been manipulated as part of that. So let's see when we're, okay, so this is the actual, we're comparing what Lex heard with what we know from the database. So that is a verified maiden name. If we keep scrolling up, this should be the elicitation. Oh, that's the confirmation, sorry. Transfer funds, this is before. So Wolf was the first name or the first slot that we elicited. So it's going to be up a little bit more. Okay, so they're saving. So next here should be. Nope, nope, this is saving. Sorry. One more. Cool. So this is the response that we're giving back to Lex to elicit for the last. Actually, no, this is the response model we got from Lex. So we gave it runtime hints, and it was actually able to transcribe that correctly. So I said wolf, it recognized because of our runtime hints, which I'll show here in a second of where we pass that in. We were able to get the accurate transcription. We validated that in the back end, and we were able to proceed with our transaction. Here is the more up. So here's the actual runtime hints that I'm using. So this is the part of the code that I uncommented and that I'm adding into the session state. I'm saying, I want to add runtime hints specifically for slot hints, for the intent transfer funds, for the slot mother's maiden name. My runtime hint values are wolf. You'll notice again that this is an array. You can pass in multiple. So like I mentioned in the example of the destination cities in the airline example, you can pass in multiple values here. In this example, we were just passing in the one. Awesome. That's what we have for demos today. Where's my mouse? There we go. That's what we have for demos today. I hope that you were able to get something out of this session. We've got some next steps on the next slide, but before we do, Alex, you want to talk about the survey here a little bit?
Sure, yeah. I'll just reiterate what Mike said earlier. We are very data-driven. We look at all of the survey feedback, and it absolutely drives how we shape future sessions. So if you guys could just take maybe 60 seconds to fill it out. I think it's 5 questions. It's really quick. We definitely appreciate the feedback. I think Mike put a QR code on one of the slides.
Oh, yep, it's on my. There we go.
Sorry, I could have said that first.
Yeah.
So we'll give you guys just 60 seconds here to complete it, and then Mike, feel free to move forward.
Yeah, then we'll take some questions.
Yeah.
There's
So
quite a
I'll give
few in the
everybody.
chat. Yeah.
Yeah, I'll give everybody a couple minutes or a minute or two to scan this and make sure that we're getting our surveys in. But Gillian, do you want to start with the Q&A?
Sure. We also have one of our product managers here today who will hopefully help us out with some of the questions.
Yeah. Yeah, we have Marcelo Silva here from the Lex product management team here to help us with any Q&A.
There's a question about sample Lambda functions. So you'll see in the links, and I believe it's up in the chat earlier, the workshops for Lambda, Lex, well for Lex, and then there's follow-on bits in it where they're using Lambda. So you can, if you go through the workshop, you will see examples of the code and examples of some of these things today. Mark is asking about if the intent is complete, usually my session is finished, but I would like to ask, is anything else? What is the best approach to do this? And then a few other things. So I think once everybody's got the QR code, I'll maybe take the screen share for a minute and we can take a look at.
And just before you, sorry, Gillian, just before you do, here are the links. I think we're dumping them into chat, correct?
Yeah, let's put them in chat as well.
Okay, perfect. Go ahead and take screen then.
If you want to pop them in chat.
Sure.
Oh, I'll take over. So Mark, you've got a few different options depending on what you are trying to do and how long you want to keep the conversation doing. So it is important to know that you completely control the flow. So the normal default for your fulfillment is to end the conversation. So in that success and failure, but you don't actually have to end the conversation. You could choose to go back to wait for users input, which is basically elicit intent again, or you could switch to another intent specifically designed to ask a follow-on question and use that for confirmation. You can see that in the JSON there for create intent. You've got the success next step and the timeout step. So here in the fulfillment or at any earlier point, you can also use these to control the path of your conversation or add conditional branching in as well based on different things. So you don't have to accept just the end conversation at the end of intent. You have options to change the path, to say to the user, is there anything else that can help? And then set it into an elicit intent, or there it says waiting for user input, or some different things like that. So hopefully that helps, but it does depend on your exact scenario. I don't know if there's, I know you have some other questions in there as well. I'm trying not to skip. If I skip anyone, please ping and we'll try not to miss anyone's questions. It's great seeing lots of questions. I love it. You asked about calling Lex from Connect. You might have spotted it in Mike's demo. When it comes from Connect Voice, you're going to see in the request attributes the channel as Connect. So that will be in there automatically if it comes from the voice channel in Connect, and you'll see that it's willing to take plain text or SSML, which you saw Mike use, which he annotated it up to say put pauses in and stuff. Now you would not want to send back SSML to a chat window because then it's going to look a bit weird for the user. You just want to send plain text. But this is in these request attributes. This is where you can see that it's come from Connect. It's come from a voice channel. But you've asked about accepting doctor versus doctor. So those differences are set up in build time. So if you've got a voice bot and a text bot, you may want to create two different versions of the bots. Or you may just need to add in enough variation if you want to use the same for both, so that you've got both words, enough. But you're getting this at runtime if you want to take specific actions for, Connect in your Lambda, because you could have your Lambda hooked up to bots from other channels as well. And then you've asked about wisdom. Mark, are you looking to respond to the user with an answer from wisdom? Is that, why don't you just come on, Mike, if you're okay with doing that, you can just unmute yourself.
Yeah, so it's the usual thing of, if you're going to integrate, most probably for chat, somebody enters, I'm trying to think of an example now. My laptop's not powering on.
Yeah.
So you haven't got a specific intent, but you perhaps want to go to a knowledge base to then suggest knowledge articles that they can click on or look at, without going to an agent.
That makes sense. So there is a Kendra intent, but if you've already set wisdom in your Connect instance, that makes perfect sense that you would want to go to that. So you could set it up just in the fulfillment, because I'm presuming you're not going to want to collect any slots or anything as you go through. So you could just go straight to fulfillment, look up, respond back to the user. If you wanted to have a little bit more of a conversation where you pulled things back, sent it back to them and said, was this helpful? Yes or no? Then you could put it up at the initial and then use a confirmation step to ask them if it was a helpful thing or not a helpful thing. So you do have a couple. Normally, if you're just doing an FAQ, you would just hook it straight in at fulfillment and just do that one shot. Here's your question, here's the response, and hand it back. But it depends how fancy you want to get.
Yeah, would you use the fallback intent, or is that just you can't do anything with it? It's just going to call the fallback.
Oh yeah, sorry, that was a great question. Yeah, normally just in the fallback intent, you would put it into the fulfillment there, try to get an answer, and then if you don't get an answer, you can say, sorry, we don't have an answer. But yes, normally in the fallback is where you would go to those knowledge bases if you didn't match anything else.
Okay, great. That gives me a couple of options. Thank you.
What is our next question? So I think we got an answer on the custom vocab and the languages. There are some questions about different accents and voice disorders. So Marcello, do you want to, I don't know if you want to make any comment on those ones? They're at 7:07 p.m. in the chat.
Yeah, sorry. Yeah,
okay.
We train our models on a variety of dialects and also accents. I have not come across this particular question before, so what we'll do is please send us. Let's grab that the information via email, and I'll provide you an answer on email after checking with the science team. What is the current behavior, how we train our models based on any particular speech impediment and things of that nature.
Thanks.
There is also a question about the best practice for eliciting a slot where the user is expected to provide a digit string, but you also want to account for responses like I don't know or I don't have it. Marcel, is there anything that you've seen? I can weigh in, but
I think one of the from a slot, I think there's a variety of things we can do, especially if it is alphanumeric or numeric numbers only. We usually want to make sure that you are right at the right state of dialogue, meaning you are listening for a slot. You have the proper slot configured. Let's assume it's alphanumeric, that you have an alphanumeric slot being used for collection. And if possible, to restrict even further the speech recognition model. If you have the ability to use regex, for example, to be able to identify, you may already know that the first four letters are always ABC and things of that nature, and the subsequent portions of it are 6 numbers. You can use a regular expression to make sure that that happens, especially for letters that may have acoustic confusion, like the PBs and things of that nature, that are hard to recognize over 8 kilohertz phone lines. So that is some of the things I've seen in the past that have made great success with the collection on alphanumeric slots.
I think if you have something you're collecting like a gift card number, if the user absolutely needs to provide it for you to be able to continue, then obviously you need them to provide it. So going to that fallback situation in which you say, sorry, not able to continue isn't as bad. If it is something where you maybe can go ahead without it, you might want to put in a pre-check. If you think a lot of users might say, I don't have it, or I don't know, you might want to ask them whether they want to provide the gift card number or something else. And that lets you then route down 2 different flows where you either then go to the gift card number, the person has it and they're going to say it, or go down a different flow and collect a different piece of information so that you're not frustrating people. But it depends on your particular use case and what's going to be the least painful for your users. Hopefully that somewhat answers your question.
Yeah, that's helpful. Do you know, is it possible to use the regex for example, those kinds of maybe a limited set of phrases like I don't know it or I don't have it?
So I think not within the alphanumeric. Sorry, Michelle.
No, go ahead, Gillian.
Oh,
Yeah.
I was just going to say, not within the alphanumeric slot.
That's correct. Not within the alphanumeric slot. Because as we mentioned, and I think Gillian alluded to this, as you try to get your ASR more and more accurate, you're trying to restrict the domain instead of going for the large corpus. What alphanumeric is doing is, once you have that, you are at that dialogue state. If you're listening for the slot and you're looking for alphanumeric, the system is pretty much looking for letters, and it will try to prioritize letters and numbers. The I don't know could be that you can create, that you could potentially, as Gillian said, use the logic of fallback, or you could create an I don't know intent. Once you are at that illicit slot state and you are eliciting for an alphanumeric type of slot input, it doesn't mean that you cannot go out and still elicit for an intent or have another intention, which is perhaps you can say, I don't know, or the fallback, but the system will prioritize that alphanumeric transcription, if you will.
Yeah, I've got the same question from a customer of mine that I'm going to spend some cycles on this week or next to kind of flesh that out. I think there might be some creative ways we can do that. If you want to drop your email in the chat, well, that's a lot of people to put your email into. Who was the person that asked that question?
This is Jesse Montgomery.
Jesse Montgomery. Okay, I can look up your email on the back end here and reach out and see if I can come up with something.
That'd be great. Thank you.
Yep.
There's a question about which use cases are recommended for the visual builder. Anything you want. If you don't want to handle the bot programmatically, which will make maintenance really handy if you're a developer, running it in code is great. You saw Mike doing that. But if you are a designer and you just want to use the front end, the visual builder is really great for just letting you kind of string it together. But be aware that what you're seeing in the visual builder, what you're seeing in that other view on the console, and what you see in the code is all the same thing. It's just different views into it. So, if you deploy it programmatically, you can open up the visual builder and just see that, what you've deployed. So you don't have to exclusively just use one or the other, or you could use the visual builder and then export that and then put that into code. So it's mostly for people who, are designers rather than developers, but you can use it as part of your flow, especially when you're sort of building your bot out at the start. Use case for confidence. Mike, I haven't let you speak. Would you like to talk about the use cases for confidence threshold?
Sure thing. So, yeah, I assume you're referring to the transcription confidence, and that confidence score can be leveraged to say, okay, if I'm collecting a piece of information and maybe it's at a 60% confidence score, maybe that's the threshold where I want to just read it back to the customer and make sure I elicited and fulfilled that or captured that slot correctly, right? Whereas if it's 90%, hey, I'm pretty sure I got this right, and maybe we don't want to burden the customer with having to confirm it again, right? So that's kind of one example of how you can use different confidence scores to have kind of a dynamic customer experience based on how their interaction with the bot is going.
Oh, Dennis, do you mean the confidence threshold when you create your bot? That confidence threshold when you create a new bot is used to determine at what point it will go to fallback. So if you set it to 90%, then Lex will have to be 90% confident that that's the correct intent before it will go to it. Otherwise, it'll go to fallback. She said at 40%. So what you can do is you can control the amount going to fallback. So rather than you having to manually check, say in your Lambda, is the confidence above what I want it to be, you can set at that whole bot level and say, look, if you are not 90% confident that this is the correct intent, then just go to the fallback intent, or I'm fine with anything over 40% or whatever you want. Is that the confidence threshold that you're talking about? Perfect. There is a question about background noise while using Connect. Mike, do you have any input there?
Yeah, not prescriptive guidance there. I would just make sure that you're using slots that are going to be for the type of data that you're looking for. For example, if you're capturing, one of my customers actually just yesterday, they were using Amazon.number to try to capture the last four of an SSN or a PIN. And they were having a lot of issues with background noise and things like that, where we're getting part of the transcription there. And we made a pivot to the alphanumeric and used regex to say, okay, I'm expecting 4 numbers here. And it was able to kind of decrease the amount of background noise that was detected, because the bot knows at that point I'm eliciting for 4 numbers, right? So that's an example. Overall, speakerphone is always going to be challenging. People in airports is always going to be challenging, or noisy environments. And while we try to have a ideal customer experience through voice and conversational AI at the beginning, another best practice is if we're detecting that the customer isn't we're not hearing them correctly, or is missing a lot of intents or utterances and things like that. Maybe offer as a backup a DTMF menu, right? So they're still able to drive forward through the IVR and what they need, and maybe it's just not an ideal experience that you would have at home in an office or something like that.
Do we have any more questions? Have I missed anybody?
We are about at time here, so we probably do need to wrap up, but thanks everybody so much for joining. I hope you guys got something out of this. Please, please, please do the survey for us. We really appreciate it. And yeah, thanks for joining.
Yeah, thanks for being here.
Thank you so much.
Take care.
Bye.
Bye.